All right, so we are going to use a table of values to help us interpret some more about quadratic functions. So the question is, over what interval is f of x equals 4x squared increasing? Over what interval is it decreasing? So just to remind you, we're talking about a quadratic function. The a value is a positive 4, so I know that this is a parabola that will open up like this. So even though both of what I just drew, each side has arrows going up, an increasing or decreasing function is what's happening as you're moving along the x-axis like this. So I'm coming in from the left, I hit the parabola, see how I'm going down, 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 down. This is where it's decreasing even though this arrow is pointing up. That arrow just means it's going to continue forever in that direction, but that arrow pointing up does not mean an increase, because when we come over from the left and we hit the parabola, we go down as we continue it. Then right here, it changes, it turns. Now I am increasing as I'm moving along. So this side right here of this parabola is decreasing. This side is increasing. So that's visually, and then I'm going to say right here is what we call a turning point, when it switches from one to the other, from increasing to decreasing or vice versa. Visually, that's what it looks like, and then let's identify that same idea from a table of values. So filling in this table of values, we've got our inputs of our x's. We're going to plug in all those x values. We're going to do 4 times negative 2 squared. Negative 2 squared is a positive 4, times 4 is 16. If you use a calculator to type this in, that's okay, as long as you are using parentheses and squaring. What you cannot do is do 4 times negative 2 and then raise that to the second power, because then you're not following order of operations. You're multiplying before you're doing an exponent. So if you're doing this in your head, do the exponent first and then multiply by 4. If you're using a calculator, you can type it all in as long as you use parentheses. All right, so that gave us the ordered pair, negative 2, 16. All right, so we're just going to plug in each value. So 4 times negative 1 squared is a positive 4. That gave us the ordered pair, negative 1, 4. Now let's plug in a 0. 4 times 0 squared is 0. So we have 0, 0. Let's plug in a 1. 4 times 1 squared. That's going to give us back 4. So we got 1, 4. And then we have 4 times 2 squared, which gives us 16. So our ordered pair is 2, 16. So what we're being asked is to identify the interval where our function is increasing and over what interval is it decreasing. So let's just make a note that function values when they say when is your function increasing or decreasing, the function values are the output values, which are the y values when we're looking at a table of values. So what we're going to focus on are the y's. We're going to look at all these numbers. So as we move through the table, because if you're going from negative 2 to negative 1 to 0 to 1 to 2 for your x's, that's the same as moving left to right on a graph. We want to see what's happening with our function values, our y's. We're going from a 16 to a 4 to a 0, so I can see we're decreasing. But then after 0, we start increasing. We're going from a 4, and then we're increasing again to a 16. So what's happening here is our function values are decreasing. Then we have a turning point at 0, 0, and then our function values are increasing. So that's kind of my little visual. So they are going to be, now we're going to write out those intervals. So our decreasing interval is, here's where it turns at 0, and see how it's all the x's that are less than 0. Now when they ask for intervals, they're talking x values, okay? So our function is decreasing for all the x's that are less than 0. So essentially that is going to be the left side of our graph. Our function is decreasing all this side over here. What that looks like in interval notation is from negative infinity all the way up to 0, we are decreasing, and we don't include the turning point, so we're going to have a parenthesis on both of those. Then they want the increasing interval. Our values started increasing once our x values got positive. So 1, 2, this is where our values started increasing. It was increasing here on the right side of our graph. So it's increasing when all the x's are greater than 0. And in interval notation, that's saying from 0 all the way to infinity, our function is increasing, and we use parentheses on those. All right, so let's just make sure this is making sense with this follow-up question. A function of the form g of x equals ax squared increases over the interval x is less than 0 and decreases over the interval x is greater than 0. What is the possible value for a, and explain? So I think a visual on this helps out. So let's go ahead and draw in. Here's our x and y axis, and we're going to focus on the x-axis. Now when x is less than 0, that's over on this side. X is less than 0 over on this side, and it says that the function is increasing over here. And then our function is decreasing over the interval x is greater than 0. Well, x's are greater than 0 over on this side. Here's where x's are greater than 0, and that's where our function is decreasing. Now we know that it is a parabola because of the x squared. It's a quadratic function, and it's going to go through the vertex. So we're going to draw in a parabola that is increasing on this side and decreasing on this side. So as we come over, we're going to be increasing, increasing, increasing. There's our turning point, and then we're going to decrease, decrease, decrease. So we can see that our parabola is going to look something like this. So when x is less than 0, we're increasing. There's our turning point at 0. When your x's are greater than 0, we are now decreasing. So what is a possible value for a? Really, your a value can be any negative number, or a negative value. How about? That says value. It's hard to read it. Let me write it in a little neater. Okay, your a value can be any negative value because the parabola is opening down. So it would have to be negative.